Okay. Once again, welcome to this middle sessions for this LTT training. Today we'll cover the module 1 and 2, which is the introductions and the power sources. And according to what I ask, if you guys have take the time to attend the online modules for you to understand is to like pushing you to get more so that in this training we can be able to discuss more and get most out of what we are sharing. Um, the content of this training today is as I said, we have the module 1, which is introductions, and in the introduction module we will have the energy in MSF context. We talk about the basic of electricity. We also talk about the fundamental periodicity in electrical installations in MSF. In the module 2, sources. In this module, we'll talk about the power source in MSF context, the power source installation requirement, and we'll move to questions so that we discuss of what we learn, and then at the end, trying to explain a little bit for the case study for each of you to work on it properly and then submit it so that in the next, like in the last sessions, we can be able to go through together, work on it, and then if there's any things that people, some people they don't understand, then we can explain more for them to catch. And then once they will be alone in the fields, they can be able to manage. So this is a little bit the idea of this part. Um, Reliable energy supply is one of the important things to save patients' life in our healthcare facility and ensure the continuity of our service in the fields. And having this reliable energy supply in our operations help us do many things. Can someone tell me what these reliable energy supplies can help us do in our operations? Just give your idea. Anybody? Having a reliable energy supply operation can help us do what?
to
Any-
run equipment, biomed equipment, to have
Mhm,
cold chain management,
mhm,
efficient and variable.
mhm. Yeah, that's right. Anybody else?
And in general, to maintain your operations, to start your activities. Without electricity, you don't have nothing.
Exactly, exactly. I think the answer you gave is the right one. And unfortunately, in most of the contexts, getting this reliable energy supply is challenging. So maybe the locations, the local energy infrastructure is either non-existent, or maybe severely damaged because of the war that is ongoing, like in Sudan. Maybe the infrastructure exists, but with reliable electricity supply. Maybe there's a fuel shortage that can limit also the operation of your generator. And lastly, the most important is the security context that can make like fuel transportation or spare parts difficult and impacting the reliability of our generator in the project. So this are the challenges that we always have. So faced with these challenges, as we are committed to save people life, we have to continuously adapt to this constraint to ensure effective healthcare delivery. Now, let's get to the basic of electricity to help you understand what we will talk about in the coming slide. Can someone define what is electricity? Anybody has an idea?
Electricity is the flow of the current in the conductor, or the flow of the
Exactly.
charge. Sorry, or the flow of the charge in the conductor. We call that one electricity.
Anybody else?
It's the flow of
Fine.
electron that carries energy.
Yes.
Okay. You guys are right. Electricity is defined as a flow of electron in a circuit due to potential differences. And the fundamental concept in this domain, like in the electricity, can some of you can name them, this fundamental concept? Yes, Ferozi, you can go ahead.
Yeah, and first of all, like electricity is a form of energy resulting from the movement and electrical charge, like electronic thread and conductor like a wire. For example, like it is the power that makes light turn on, mechanic works and device charge. And especially in MSF, like electricity is used to run medical equipment, lights, fridge, cold chain, and communication system. And there is two type, one is direct current DC, like flow in one direction, use it to batteries, solar panels like this. And the other one is like electronic alternative current like AC, change the direction regularly, used to homes like generator and city power. And the key terms is voltage, pressure to the pass electricity, and current flow of the electrical charge. And the last one, the power, how much work electricity can do. Like power equals voltage, what you call the with the current. And electricity is essential in MSF operation to save the life and keep system running. Thank you.
Thank you. Exactly. And then, as I was saying, as we have logistician with us, we just want to keep it very short for them also to understand. So basically, because they don't have this electrical background, all this one will be a little bit difficult for them to understand. So we can just put it in short, like electricity is defined as a flow of electron in a circuit due to the potential difference. And then this fundamental concept in this domain is, as you mentioned, we have voltage, which is the potential difference expressed in volt, and it serves as the driving force. I will give you an example here. If you see the picture on my right, okay, we have three boys, one in yellow, one in green, and one in red. The yellow one is the voltage. Can someone tell me what he's doing here?
He's pushing the ampere. One of the work of the duty
Look,
volt of this to pressure, to do the
is
pressure.
no, yeah, just in term of the color, like these are three boys, yellow,
Yes.
green, and red.
Yes, the yellow one pushing
Is
the amp, the green one.
green one. Uh-huh.
Yes, on the also
Okay.
the red one is hanging the green one, not let him to go,
Okay.
which is
Okay.
resistance or room.
We go step by step. The yellow one, which is voltage, potential difference, is pushing the green one, right? Now, the second concept of this one is called current, which is the flow of electron in the circuit. Now, this green guy is the current, and he's driving by these yellow guys. I hope everybody understand.
Yes.
Yes,
Okay.
it's clear.
Then, okay, then the third one is the resistance. This red guy, what he's doing is restricting the green guy to pass. So this is the resistance. In your cable, when the current is passed, you have this resistance that is reducing the flow of current. So this image that you see here clearly reflects the relationship between these three concepts that we have. And you can use this Ohm's law, okay, to determine the current, the voltage, and the resistance. And this is something that if you get used to, it will help you a lot doing a basic calculations as a logisticians. Okay. And this movement of electron due to the potential difference that we talk about is called electrical energy. Okay. And this electrical energy is measured in kilowatt hour, is the total amount of power consumed or generate over a period of time. Okay. For example, if you have a device which has a rating power of 100 watts and it's operated that you can also convert it to kilowatt hour. Okay, so this is the energy consumed by this device. Now, the rate at which this electrical energy is transferred or consumed in a circuit is called electrical power. So if you see the formula, this is, you can see that we have the basic concept, the concept of this electrical inside that help you do the calculations. What I'm showing this is because in your case study, okay, when you will go to look for the device that you have in your case study, on the device nameplate, sometimes you cannot find the power, the electrical power. You will just find the voltage and the current. And you are the one going to do the calculation to get this power and enter it in your generator sizing. So this part is very important for you to write it down and then remind, because it will help you during your case study. And this parameter described by the Ohm law are essential, as I said, for designing and analyzing our circuits. And then understanding this relationship among the parameter will also allow us to optimize our circuit's performance, ensure safety, troubleshooting electrical system, and everything. It's basic, but if we know them, it will help us understand more things. Even if you are not too much used to, someone is a little bit far, it can help you like solve some issue in the field. And I talk about the nameplate, and it's very important for you to catch this one, because as I said, in your case study, this is one of the exercise that you will do. Okay. For example, we have a laptop. Okay. Mostly people, I don't know if you guys see clearly the image. On the top, you see is 45 watts. Okay. But basically, this is the DC power. This is the output of this adapter that they put here. But people, they don't know. They just pick this one and then put it in the generator sizing, which is wrong. So here, if you see it closely, you will see they mark the voltage, the range of the voltage sometimes is from 100 to 240 volts, and sometimes it's 100 to 230. And then they give also the amps, the current in this nameplate. And these two value can help you determine the power that you need that can help you enter it in the generator sizing. On other devices, for example, for this one, this is in the, I think it's the lab, it's not too clear, but you can see that they didn't put the voltage, the amps, no, they just directly put the power. So you can just pick it from there and then put it in your generator sizing and you can use it. But in case you don't have this one, you have to do this basic calculation that I talked about like a few minutes ago, so that you get this and then help you move forward. The other things is the oxygen concentrator that you have, for example. Okay, on this, you can also see the power directly. It's not
Caleb,
too clear.
sorry, there is a question. Sorry, Caleb. There is a question from Gaza.
Yeah.
Sorry, Caleb, can you please explain what is the 45 watts from the first lecture?
The
I understand it's not
is
the power, but what is it?
no, it's the power, but it's a DC power. This is the output power of the power adapter. But the input power before converting to DC is not this 45. You can see if you take your laptop, you can see they put input voltage. Okay, input from 100 to 240, and you have 1.1 amps, 50 to 60 hertz. So this is the power that you have to calculate and then use it in your generator sizing, not the 45. The 45, if you see the sign, is a DC, is 2.31 amps, 45 watts. This is the 19.5 volts. This is the output of this. And many people, they make a mistake to put this value in the generator sizing. So this is one of the things that you have. You have also a laptop in your generator sizing. So that's why I put it here for you to start thinking about. For the oxygen concentrator, you don't have, for this one, they just give you the power. So you can just use the power to enter it in your generator sizing and it can be done. So this is a little bit the things. Anybody have a question for this? No. So we can move forward. Okay?
Yeah, Caleb, there is a question.
Yeah. Bermed?
Yes. My question is just to clarify. Yes, I don't know if I understand well. We can't use these 45 watts to calculate. Yes, we have to use the input current.
Input current and voltage. Yes.
Yes. In this case, we will use the minimal size or
no,
for example, I will use 20.
You use 240 volts. You time by 1.1 amps because we see the formula. If I go back.
Yes.
Okay. This is the formula. The power is the potential difference time the amps. The potential difference, which is the voltage, is 240 that we receive from the generator. Okay. And your current is 1.1 amps. And if you time, you are around like 400 something watts. But people, they make some mistake and then they put 45. If you read properly on the adapter, you will see that this value is a DC value. It's not the AC value.
Okay.
You understand?
Yes, I understand.
Yes. So this is the things. Okay, if no other questions, then we can move forward. And knowing that electricity means it is also time to know how it's generated. So basically, electricity is generated from both renewable sources, such as solar, wind, and geothermal energy, and non-renewable sources like coal, natural gas, and oil. So this generation can be achieved using different methods. Okay, electrical grid, generator, solar panel, inverter, batteries, etc. So these are things that can help us generate generate power. Any things for this? Any question? Okay. And in MSF, we have 4 main priority. Can someone tell me the 4 main priority that we have in MSF when doing the electrical installations? Okay. The first one.
The first thing when we are going to install something is the first one is safety, and
Okay.
the second thing is to protect our device safe, and the third one is continue the project safely.
The continuity of the service.
The surface, and in the first for the safety, we are going to use like RCD on grounding system to protect ourselves and our colleagues and people, and also for protecting the devices. You can use the regulators and also limiters and the UPS in some area. And for having a continuous system, we have to install as per the MSF standard. You should use standard tanks. And also the last one, I think that's the environment and also our economy. So we have to use the tanks up to the lifetime, like generators. We have to use at the time that it has a standard lifetime. When we use more time, it will affect on the environment. So, and also regarding the economical, it's depend to the safety at the first. For the economical, we should at the first we should think about the safety. Like we are going to install switches, we have to bought the economical one, but it should be standard to be safe. I don't know if I explained.
Yeah, I think you mentioned a lot, and I think it's clear for the safety. For individual, we have to like install a proper grounding system, and also in addition to that, install an RCB that can be able to like trip in case of anything's happen to protect the people around. The second things is the protection of our equipment, okay, and is protection against fire, overload, the power instability that I mentioned. You can have a CTE power, but it's not reliable, okay, and even our generator, even if it's new, when you start during the start, you can see that the voltage is fluctuating. When you are switching off is also. So having these devices can help us protect our equipment. We have also the surge protection device, which can also protect from the lightning, okay, and mostly this voltage stabilizer we use a lot in our project and in the missions, and this has like this this is MSF recommendations, and it's having 2 functions. Is playing the role of voltage limiter and also voltage regulator. So once you have this one, it's like you have the combination of this. Okay, I don't know if you guys see my my mouse. The combination of VL.
You can see.
Yeah, a combination of the voltage limiter and the voltage stabilizer. So this one is playing the role of this one and another role. The third one is the service continuity. Okay, is the protection against service breakdown, failure of power source. Okay, so whenever or whatever we do in our project, we have to make sure that we have a proper plan for maintenance to keep the system working. It's the same thing like you buy a car. Okay, it's not like you buy a car, it's finished. You have to take it to the mechanic for the servicing and everything to check, like periodic service. So it's the same thing with our electrical installations. That's why we have mission electricians, we have project electricians, we have energy specialists that coordinate together to make the system work for the hospital to continue helping people. And the fourth one is the cost control and environment cost. As you explained, we have to make it such way that we control the costs when we do the electrical installations. And for the environmental care, we have to also set this waste management in order to keep our environment clean. And as MSF, we are improving in terms of, for example, reducing the carbon footprint. We are now installing the solar system to reduce. So this is kind of things that we are doing to keep our environment safe. Okay, any question for this? Yep.
Sorry, sir, I have a few questions regarding these things. Because I'm facing every day with these challenges. So at the first, my question is this, sir, that in our project, we have generator and also grid power. That at the first, in the beginning, we have a big regulator installed in the system. But inside
is it a three phase?
Yeah,
or single
it's a
phase?
three-phase. It is a three-phase regulator. Sorry, stabilizer.
Okay.
Yes. So, but inside our project for the AC, like for ACs, we doesn't install anything for protecting the EC and other system, like voltage limiter. It's necessary we should install voltage limiters for all our ACs. So because I faced with one problem, like 1 month ago, even we have regulator in our system, but from the panel board, one times instead of one neutral, a phase will it come, and the volt become like 400, almost 400 volt, and it affect on the device, but then fortunately, there's not happen. So it's important to install voltage limiters for all the ACs, or you're using something like this.
Yeah, I think for a quick answer, basically your AVR, the voltage stabilizer is having problem because normally he has to regulate the voltage in such a way that is stable, and also you cannot have this face-to-face value on the distribution box. If you are having this mean your voltage stabilizer three-phase is having a problem. And one of the things is that in the input sometimes, okay, you can see that if you don't have an automatic things to regulate the input power, and if the phase change because of the city power, this is happening a lot in my country. Today you find that the phase become the neutral, or you can find that the phase one become the phase two, and things are changing like this. So if you don't have a system that is protecting the input of this voltage stabilizer, for sure the three phase it will not work properly, and the value you are getting in the outputs clearly is telling you that this is not working properly, and you have to either find the special technician for him to check, or find a way to replace it to not damage all what you have in the facilities.
So we should not install the voltage limiter when we have voltage regulator.
No,
Am
we
I
can
right, sir?
have no, we can install it. What the voltage limiter is doing is just checking the range of the voltage that he's supposed to check. If it's out of it, it's just disconnect, and then your device still safe. So you can install this, and then you can install your voltage limiter on your device. Is fine.
Due to this, I asked this, sir, in our project, we have almost 300 or more than 300 PC installed. We have already 5 full hospital. So if I'm going to order voltage limiter for all of these PC, you know, sir, it costs lots for our project. So
Exactly.
we have a
But
stabilizer at the beginning. So what do you advise, sir?
yeah, so as I said, if your voltage stabilizer is good, providing the normal output, you don't need it. But for safety, for your devices, it's good to have this voltage limiter. Okay, it's not like mandatory, but according to what you explained, you didn't know that the situation will happen, but unfortunately it happened. So if it's happened, how many AC you will lose at this time?
Got it, sir.
You understand? So
Yes, I
putting it
understood.
is true. Yeah, putting it is true, is expensive, but it's good to protect. This one is less expensive than the ACs. So you lose one AC, or you lose the device. So this is the things. Okay.
So I have one more
Okay.
question. If our colleagues doesn't have any problem.
Yeah, but because of the time, also I will take the questions. You can keep it at the end. Write it
Okay.
down, and then we keep discussing, because we are running out of time. So we have to move a little bit fast. Okay.
Okay.
So as I said, reliable energy supplies is important in our operations, and understanding the fundamental concept of electricity, prioritizing safety, protecting equipment, ensuring service continuity, and managing costs with environment things will help us a lot. And as a logisticians that don't have enough knowledge in this case, it will be good that you keep practicing, and you ask for your, if you have a project electricians, you can just have like 30 minutes with him, so that he can also explain a few things for you. There's a training that you can ask also to keep like refreshing what you have learned, so that you can be more consistent in what you are doing. Okay, we'll pass to the module 2, which is the power source. Any question for the module 1? Just quick one, not long.
Yes.
Okay.
Sorry.
Yeah, go
Just
ahead.
yes, just I would like to give some information that sometimes we can use a voltage. We cannot use a voltage limitator, because when he cut the current, he's don't switch on again the voltage limitator, and then some kind of equipment we can't use this voltage limitator. For example, has a how can I say, a cold chain, active cold chain. I think so. No.
No, the things is that the voltage limiter, you have to choose it according to the capacity of your device. Because if you are using a device that has, for example, a 10 amps current, and then you choose a voltage voltage limiter that is having less, it will have problem. This is what people they forget when they want to choose this kind, they want to buy this kind of things. So before you buy this, you have to make sure of your devices, the capacity of your devices before buying it. And when you buy, you have to buy the one which has a little bit, okay, which is a little bit higher than the capacity of your device. And this, it can work properly. And also the quality, that's why we talk about the device must be from a validated supplier. And always we advise for this kind of things to make an international order for solar tech, that you have it in a project, and then this can help a lot. But before you order, you have to make sure of the capacity of your devices before you order. Otherwise, you make mistake, you order what you have to order, and when it's arrived, you are not able to install them. So, and this is a waste of money. That's why we talk about cost control. You understand?
I understand.
Yeah. Okay, so for the module 2, I said is the power source. And power source refer to the system or device that generate, supply, or store electrical energy necessary for our daily activity in the field. So they can include renewable energy source, such as solar panel, wind turbine, as well as conventional source like generator and electrical grid. Okay, and being the backbone of our operations, without this power source, it will be likely impossible to ensure interrupted healthcare delivery, facilitate medical equipment functionality, and lastly, enable communication in our mission. We all know that communication is one of the most important things in our operation, because without this one, it will be difficult. That's why we always put communication things in 24-hour power, right? So power source is very important for our operations. That clearly means that we have to, when choosing this, to be very careful when we are doing the selection for this one. So as you already know, MSF, we work in different kind of contexts where access to reliability of energy is impossible. Okay, and for this situation, we should have a well-defined source strategy that can help us make a right choice, as I said, of the power source that we need for our project. So this energy source strategy that I'm talking about need to consider 3 important things. Okay, the first one is the type of crisis. The second is the locations. And the third is the need of the facility. So before you do this, as I said, these 3 important things must be checked. Type of crisis, when you do things, is to see, is these locations, okay, as a conflict, is it a conflict zone with limited power infrastructure? This is what you have to think. Is it a natural disaster place with damaged power grid where you have to set up everything, or a region that basically lack access to energy source, like you don't have nothing, you have to set up the system. And when you have this strategy, these are the things that you have to think about. When I talk about location, is for you to think, does the area have enough, for example, sunshine? For example, if I want to use solar panel, or it have fuel that can help me run my generator. So if I have to choose a generator, I have to make sure that the location that I'm going to put my generator, I can be able to get fuel. If not, this can be impossible. You bring your generator, but you cannot get the fuel to run it. Okay, it's the same thing. If you have, for example, a solar panel, you want to install a solar panel, you have to make sure that the irradiation in this location is good enough for you to have a proper production. If not, you just buy the panels, but you waste money. So this is kind of things that you have also to analyze before you choose any power source. The other last and very important one is the need of the facility. And this need of the facility, you have to estimate, or if you have medical team or something, you can ask, okay? They can provide you, and then you can be able to estimate your load using your power generator sizing tools. So this strategy will not only help you to do the right choice of your power source, okay, but it will also ensure that no matter the context, you can still provide medical care without reliable power source, with reliable power source. So you have to be very careful when you are thinking about buying this generator. And these 3 points that we mentioned, if you think and you analyze well, the choice that you will do there will be the right one, and it will be good for a long run. Any question for this part? Okay. And the type of power source in MSF context. Can someone give 1 or 2 examples of power source we use in MSF?
One is great power. This is the first period to use. And the second is generator, and also solar panel, inverter. So for system we have already in our project, and also we have backup system.
Yep.
Battery backup system.
Yeah. So we have city power, as you mentioned, generator, solar panel, inverter, battery, UPS, etc. So these are the things that we basically have in our project and then in our missions. Okay. So some of these power sources are used as a main power source, and others are used as a backup source for sensitive equipment, for example, like equipment that need to be operational 24-hour a day, like the communication equipment, like cool chain equipment. These are the things that sometimes is also good when you are planning your energy power source, is to have all these things in mind to, as I said, make a right choice for this. So before choosing any of these power source, we should also know which kind of project or which kind of activity we are planning the power source for. Okay, is it a regular project or is it an emergency project? So if you take also this one in account, it will help a lot for you to determine which kind of power source you need and for how long you need. Okay, and for example, for the load analysis, okay, once we define the project or the activity that we want to do, from there we can proceed with the load analysis. Okay, you define project first, and then from there you see what will be used, because emergency project and regular project is two things different. So you have to evaluate based on this one to make your things. For example, for emergency project, is an estimation. You don't have anything. You have to start from scratch. So with the estimations that you have, okay, you can be able to size your generator. That's why it's important for you to also check with the medical team what are they going to use. Then you list down. You can go to Unicard. Okay, if you don't have anything, you go to Unicard. You start looking at these informations, and then you can be able to size your generator. Same thing for your backup system. If you want to use an inverter with batteries, okay, you have also to list down what you want to put on this, so that you make your sizing according to what you have. For regular project, you can use, for example, ammonia, which is energy meter. You can use this other power analyzer, which is called Kiryotsu. Okay, I can show you here. This is ammonia that you can order in MSF Logistic. Both, if you check in on Unicard, you can get the code, and they can be able to order from MSF Logistic. And this, for regular project, you plug it, you leave it for 1 month, then you can also see your consumptions. Okay, how much you consume per day, how much you consume per month. And based on this one, if you want to go solar, it will help you quickly move forward with the this is picture for the generator sizing sheet. In OGBA is a little bit different, in OCP is a little bit different, but still the same. It's still the same. And the other one is the backup sizing sheet that you can use. Sizing and selection of the main power source. In MSF, for the sizing, as I said, we use these two tools. But now during the sizing of our main power source, there are a few things that we should consider. Okay. The first one, we should know the altitude above sea level of our locations where we are. If, for example, I'm in Malakal, for example, I have to check on Google what is my altitude above sea level. This is one. And then I have to know what is the temperature in these regions. Okay. And once you are doing your sizing in this generator sizing, the value that you have to get should be 30 to 80% of the generator capacity. If it's less, then I will show you what it has by fault. Okay. And the generator sizing, as I mentioned, you have to check your altitude above sea level and your temperature. The design of the software is done by the default conditions: 100 meter above sea level and 25 degrees temperature. Now, if you size for OGBA generator sizing, if you size your generator and you are in the location where the altitude is more than 100, let's say 200 or 300, and the temperature is 35 or 40, you have for the altitude, if you go 100 more, you have to add 1%, okay, on the capacity of the generator. If your temperature is more than 25 degrees, each 5 degree is 2% increasing of the generator capacity. So for OCP generator sizing, they already put these two so that you can enter the value and then you get. But for OGBA, we have with this default condition that you have to use it. Once you use it, at the end, if you know these two, you can add up all this percentage and you add on the generator capacity so that you recheck what capacity of the generator you have to choose at the end so that you can be able to power your load.
Philip, can
Now,
I ask a question? Sorry.
Yes, go ahead.
What is the relation between the height and then increasing the power, for example?
Yeah, when the reason for checking the altitude is that when you are going higher, okay, above sea level, the oxygen is reducing. So your generator, okay, your generator combustions will not be as you want, and it will decrease the engine power output. You
And
get
it
the
will
point?
heat more,
So,
no?
exactly. So this is kind of things that you have to check before you move. And also the temperature affect the generator. So if you go more than 25, like we said, 5 degrees more, you have to add 2% on the capacity that you have on the sizing.
Super clear. Thank you.
Okay. Now, selection of the main power source. Okay. Now that we get the size of the main power source, we have all the idea to choose. Okay. Now is to see, according to what I explained, if you are doing, for example, your generator sizing, okay, you should be around 30 to 80% of the generator capacity to use. But if you are less than 30, okay, our standard advice that you use, instead of using a generator, use an inverter with backup, with battery to run your system. This is from Ogba's side, okay? I don't know for other OC, but this is a little bit what we have as a standard. Now, if you search your generator and you are up to 12 kVA, it's advised to use a single phase generator, no a three-phase generator, okay? And if you are around 12 kVA to 15 kVA, according to your load, you can decide if you can go single phase or three phase. Because with the three phase, you can be able to balance your load properly if you have a good electrical installations. And above 15 kVA, you have to go for three-phase generator. There's no discussion about this one. Okay, and for most of our project, the generator that we use have different engine speed. I hope everybody agree with me. Different speed. We have 1,500 RPM. We have 3,000 RPM. And mostly we use 1,500 with this lowest speed. The advantage of this one is that this generator can run for even 10, 20 days. The only thing you have to do is just to stop to do the maintenance. Otherwise, it can keep working till you are the one decide to stop. It's quite, because some have canopy and all these things, but those who doesn't have canopy, you can find a way to put it in the room, whatever, to reduce the sound. Okay, but the other things is they are expensive. They are expensive, but they are good. They can run for many days. And for our project, we know that is running 24 hours. So we need this kind of generator to help us power our hospital. So if you are doing your generator sizing, the things that you have to put on mind is, yes, this hospital will run 24 hours. So I will need this generator to work for me. I will work like 12 hours, and the backup also will work like 12 hours, and then we can be able to balance. For the small generator, for those who has 3,000, okay, this we can use them as a backup generator. Like you have a city power, you have it. If the city power is off, the generator can run like 1 hour, and that's all. This kind of generator cannot run for many hours, and it's always breakdown, need repair, a lot of headache. That's why we always avoid them in our missions. We have them, but for specific things. Sometimes some people, they have it like for OT, especially for OT or for cushion. If there's anything, they can just start for 1-2 hours and then be able to switch to the other one. So this is things that you have to put in mind when you are doing your generator selections or you're choosing your power source. So these are the generator. Okay, the small one is a petrol one. Okay, for DMC things, activity, they can use it. This is the one that I talk about, the standby 3,000, that we can use it. That is Pragmac. I don't know if some of you still have this one in your project. We have the other one, which is 11 kVA, still 2,300, 3,400 RPM. And this, as I mentioned, can be used for backup only or for few hours or running. And the one we use mostly in our project is the 1,500 that can run for long. That the only thing can stop if you want is the maintenance. So this is a little bit what I can say about this one. Then backup sources are, as I said, secondary energy system that activates when the primary source fail. And it's our facility. We use this backup source to guarantee an interrupted power supply. So the few examples that we have include the generator, especially FG Wilton, because our standard is FG Wilson and Caterpillar. For inverter, we use always Victron and extender. And for UPS, for example, we always advise for Delta Aplon. And for the batteries, we advise more for lithium battery. And the most that we use actually in our solar project are BYD and Pylon Tech. So these are the best battery that we have that we are using actually in our project. What is also important to take into account is the power source installations. Sometimes we are in a hurry, okay? We're in a hurry, like for the emergency things, we just buy the generator, we put it without any. This is a little bit not good for the generator because you have to control, okay, the exhaust. First, you have to make a good slab for the generator to sit properly. Okay, because if the generator is not sit properly, it will start having problem with the alternator and the engine because of the alignment, and this can affect your generator. So the first thing is to start making your slab, okay? And we have also all the specification for this slab. We also have this shelter that you have to do, respecting the space that you need to put around. For example, for the generator, you have to keep a distance around for 1.5 and the height is around 3 something. So all this is the rule that you have to respect so that you have your system work. And one of the most important things is to ground the generator, and it's depend on the earthing system that you choose. If it's a TT system, you have to make sure that you respect the rule of the TT system. In the TT system, the neutral of the power source is grounded differently, and the mass of the equipment is also grounded differently. And the distance between the ground of the source and the equipment must be 20 meter away from each other. So this is one of the things that you also have to take in account. The generator exhaust is also one of the things that you have to. Mostly people in hurry they forget, and they don't put the exhaust pipe, which all the exhaust when the generator is running is full in the shelter, and the same things is the generator is aspiring and then do the compression to keep working. This is not good for the generator. So we have to extend the exhaust pipe out to evacuate the exhaust guys so that our generator can work properly. For the inverters and all these things, we have to put them in the dry place. Some inverters nowadays, they can be waterproof, but it's good, okay, to check the specification of this. If you have to put it inside or you can put it outside without any problem, you have to verify the specification for this one. But basically for this Victron inverter, it's good to put them inside, ground them properly, okay? And when you are doing your installation, you have to make sure that everything is all right before you leave the site. Otherwise, you will start getting problem with these things. These are the shelter that I'm talking about. We have, if you check in the logly, you will get this design. We have all the specification there. For logistician, if you're in emergency, please go to logly. If it's Ogba, you will get this, and then you can be able to set up properly your shelter for your generator. For the generator that doesn't have canopy, okay, if you see my screen, they put them inside. But before putting them inside, you have to make sure that the radiator, okay, you open the wall to the same size of the radiator, you put it there so that the heat can be generated outside, not inside. You remember I said the temperature can affect the performance of the generator. So if you don't do it, imagine you can increase from maybe 35 to 45, and then this can affect the performance of your generator. You have also to open Okay, at the back of the alternator, you have to open the window so that the air can flow to the generator and then evacuate it to the other side. And you have to keep also the space for the maintenance purpose or repair purpose. So this is basically the things. I already talked about this one, but for the electrical one, we should have this main distribution box close to the generator so that we can be able to connect it. And this distribution box must has the few things that we talk about, okay? The protection of people and the protection of equipment, which are the most important things inside. And then the other things can come in. We have the circuit breaker, the RCB. We can add the surge protection device type 1, mostly for the we can add it so that we can keep our system safe. So this is a little bit, sorry for being so fast because of the time. We also have some question that delay us a little bit, but we still have, I don't know if we still have time, Mikel. So we can just
the session is
just
planned for almost 2 hours, so you have plenty of time.
Yeah. Yeah. So if you have any questions, anything you can ask, you can share. Anybody have, as I said, we cannot cover everything. If anybody who has also electrical knowledge that want to share with the logisticians to help them, please, you are welcome. Okay, but not to be too long, just to be short so that we can be able to manage our time. So any question that you have based on what I explained, I was a little bit fast, but so sorry for this one, but we can go slowly in the questions so that, yeah, bulk technicians.
Sorry, sir. I have a question regarding the grounding rod. So in MSF an IRC electrical guideline book, I read about the grounding rod installation, but I didn't catch clearly. So when you are going to install a grounding rod like a 3 meter or 2 meter, we have to pour some salt on also coil or other things because in here in Afghanistan we have good soil. There is no any sandy area and also rocky place, so it needs to install a coil, some salt on the grounding rods. We have to or not, sir? And just we should drive a grounding rod simple.
The first thing, the best way to do is to test the resistance of your ground. If you have the earth resistance test, this is the first. This can tell you what is the resistance of your soil in your area. Okay, and then yeah, people mostly they put soil, they put salt with charcoal in order to reduce. What they are looking for is to reduce the resistance of the ground. But we have another also option that is also good. If you test that you see your ground resistance is high, you can add, okay, 2-3 grounding rods and you interconnect them. This can help also reduce the grounding resistance for you to have a proper relation between the RCB and the grounding so that it can properly protect people as well.
Okay, sir. And one thing more regarding the grounding system, as we know, this grounding rod is for the safety of the people, okay? And we have one thing more, earthing rod. It's for the protecting of the structure. I didn't, in MSF standard, it's required to install or not? Air terminals.
I didn't get your questions.
Air terminals rod for the tenders.
Yeah, the lightning rod.
Yes, yes.
Yeah. No, the lightning rod is depend on the locations that you are. If you have, for example, I forget a little bit, but in the area where you have, like during the years, you have a high number of thunder. I think is around 16 something. I will check and then share in the link. And there's also a site. Okay, there's a site that you can check this number of strike in your area that can help you decide if you can install the lightning rod or not. And then if you install the lightning rod, you have to make sure that your lightning rod is covering all your area. And then the trees that are around must be under this lightning rod. Otherwise, it will not come back. It will take the road with the trees, and this can be very dangerous. And when you have a lightning rod, you are ready to attract the lightning strike, and you have to make sure that all your distribution box, you have the surge protection device, everything is set before going for this. So you have to be very careful when you are doing this one. You can check with um, your energy manager or your energy specialist, or maybe your energy reference that can also support you on this.
Thank you, sir.
We have Noel.
Hey guys. So a quick question. You gave advice for generator slab, for stability, for exhaust. Any advice for noise traps? Do you use sandbag, brick walls? What do you recommend if we were to use that?
To use what? I didn't get your question properly.
Noise traps for generators. How do you prevent the noise from a generator? What's the most common use?
No, we have generator that is already come with canopy. Let me show you. You see this generator? This is the canopy one.
Yep.
Okay. And this one is reducing the noise. When you buy the generator, if you see even in the data, technical data, you will see the decibel. I don't know, is it the one in English? You will see the decibel of this generator, and based on this one, you can be able to locate your generator. But this kind of generator, the sound is inside. If you open, for example, your generator, if you did it one, you can see that inside you have these black things that they put. This is to reduce the noise of the generator. But this one is the generator without canopy. That's why we advise to put it inside the room. Okay. And inside the room, you can be able, as I said, you have to open the window from one side and open the other one so that the generator can take the intake air and then extract the hot air, so that you cannot have the hot air in the generator room. And this kind of generator, you put it a little bit far from where you are, so that the noise cannot be can disturb you. That's why we always advise to not buy this kind of generator, but to buy this one to reduce the noise.
Sure. Thank you.
Yeah. We have Damascus.
Thank you very much for all the information. Just I want to ask about the SPD charge, how it works, and can we use without grounding? This is the first question. And I have another question about TT grounding.
Wait a little bit. How is it used, or how is it work? And
Yes,
then
how is it
can we install it without grounding?
Yes, or we have to install another road, not the same grounding of the building, or the same road is good?
Okay.
And
The search pro. Okay. Go ahead.
another,
Finish.
the second question is just for, as you mentioned about TT grounding system, that the road of the generator must be have a minimum
20
distance
20
25
meter
meter.
away. Minimum is 20.
Minimum. That's a big problem that we are facing in the city building, because no a lot of area around the office or around the building or guest house if we have. So can you give us why we need this distance, and if there is another solution in the city, I mean.
Okay.
Thank you.
Okay. You have two questions. Search protection device, how it's work. The name also tell us that this search protection device, when there's a strike, okay, is gathering all these search in the circuit to send it to the ground. Because if you see the search protection device, you have this main power that come, and you have this ground line that is connected to the grounding bus bar. So whatever happened, he's collecting everything there to send it to the ground. If it's not there, maybe all your cable will burn. Maybe you will burn all your equipment. So his role mostly is to gather all these things and then send it. That's why we always advise that if you are installing an SPD in your distribution box, you have to make sure that the sections of this ground cable coming out from this SPD must be big enough to carry the current that is going. If it's very small, I see somewhere people are putting like 6 mm cable, but this is a very big mistake. If there's anything, this will burn. So we advise minimum will be 25 mm or bigger than this one. Okay, and then the other question is, can we install it without the ground? It means if you put it, it's useless, because he has to take all this one and send it to the ground. If there's no cable to send it to the ground, it doesn't mean anything. Whatever will happen, then it will happen. Understand? So he has to have this link to transfer this energy to the ground, this current to the ground. And for the TT system, as I explained, the neutral must be grounded separately, and the mass of the equipment must be ground also separately, and the distance 20 meter is to avoid interference between the two. Understand? So if we don't do it this one, you will start having a lot of problem with your systems. Because even for the grounding road, okay, for the grounding road, you cannot install grounding road like this. Okay, you have to give like at least 1 meter or 1 meter more to avoid this interference that we are talking about.
So you mean maybe some current will go from our generator to the city power?
Yeah, and this is one of the problem we are having actually in Jamena office, in Chad office, that the guys doesn't know the principle. He just install the things for the generator close to the other one, and they start having all the problem, and they don't know where the problem is coming from. But the thing is, they didn't respect the rule. When you are using a city power with the generator, you have to implement a TT system, not a TN system. If you are installing a TN system, it means you are burning your things. And this TT system must respect the rule that we have. And this is what they were obliged to disconnect all these things.
Thank you very much.
Anybody? Yeah. Any other questions? Okay. As I said, is to briefly give you an idea of the case study so that you can be able to work on it. Today we cannot be able to work on it because we want to give you the idea on it. You work and you submit it, and then the last sessions we can be able to go through together, and then we see what we can do to help you improve more and then be able to work. Even you are alone, you can be able to size your things. If you have something for advice, okay? So in the case study, there's 4 questions, right, Miguel, if I'm not wrong? Yes. So the first one is define the power strategy for the health center, define the power need, the engine, speed. Remember what we talk about. The power need, the engine speed of the generator, and they recommend a generator sizing. Generator size. So based on this one, according to what we explain, according to what we discuss, it can also help you for this when you are doing your sizing, to help you choose your generator. And then we talk about the shelter, proposed generator shelter design. You can just draft anything. No need for too much things. You can draft if you want. You draft or you tell us just the specification, how you things to do it, and then we can see together. And then the list of material to be ordered from MSF Logistics. Okay. Now, the case study. Okay. Maybe I will show you something. But we expect from you to create a proposal plan to solve the case study. And doing this way, you will learn a lot. You will not learn a lot. You will not need for the electrician to do it, or you will not wait for the energy manager. You can try, but you can still ask for advice to do better. Okay. I will show you a little bit the things. Sorry, I will disconnect. No, I have it here. It's fine. Okay. So if you go, okay, on the location that they're asking you to install your generator, do your generator sizing, as I said, before you go there, before you think, you have to put things down, try to understand, okay, the locations, the need, whatever. Is it the emergency project? Is it the regular project? All these things you have to take in account. And once you come here, I will advise you, when you click, you just put the mouse on the point, you will see what is asking. For example, emergency room, what is the load there? You write down under the emergency room, you write down the load. You go to warehouse, you write down the load. You go to lab, you write down the load. Once you write down the load, you can go to Unicad that I show you, okay, before. All of you knows Unicad?
Yes.
Okay, so you go to Unicad, you type, and you can check for the power consumption of this, the power of this load. The best one to do if you are in the project, actually, okay, you can go to the hospital. This is a setup for hospital. You can go directly to the hospital. You go to the lab, okay? According to what I show you here, let me. Yes, you go directly to the lab. Okay, what is listed. You check the nameplate. You see if you have the power already in what. You just write the name of the things and you write the power in front. If they don't give you the power, just check the voltage and the amps, and after you use the formula that we show you to do your calculations, then you can get your power and you introduce in your generator sizing. So for each locations, go, if you are in the project actually, you go, for example, to the lab, you take everything, you go to the ER, you check, you go to the or maybe warehouse or the small one that you have. Okay, you check everything, and then now if you come, you sit down, you can be able to enter them in your things. You can go to the radio room for VH or VF equipment that we're talking about, and then you see how you can get this thing. So this is a little bit what we can give you so that you can work on the case study. And then yes, if you have any questions, please you can put it on in the chat, so we can also help you. Yeah, we can help you so that you can move forward. Yeah, I see question. Someone is raising his hand.
Yes,
Yeah,
yes,
I
yes.
did.
Was me.
Oh, sorry. Go ahead, friend.
Yes, my question is it necessary to show the calculation, or just we need to put the last value of power?
No, if you have the power already there, for example, in the
Yes.
oxygen concentrator, you have like 450 watt. This is the only thing
Yes.
you need.
Yes, yes,
Okay, but if
yes,
in the oxygen concentrator you didn't see the power, they just give you the
yes,
voltage and they just give you the current. You take the two value and you do your calculation.
yes,
Voltage
yes. And
time
then,
current. Mhm.
yes, my question is necessary to show the calculation,
No,
or
it's not
just we need?
necessary. It's just the value that you need that you will put in the generator sizing.
Thank you.
Exactly.
Uh,
Other question?
quick question. Yes, thank you, Caleb.
Yes.
If I
Yeah.
go to Unicat to try and
Mhm.
find the power plate for an oxygen concentrator, I
Mhm.
believe there are different models. Should we just pick one? Is it described? I didn't get to the case study yet.
No, you can choose whatever you want, because I think
Okay.
they didn't specify.
And there's not much
Okay.
difference between one and the other, yeah?
Yeah. We have
Okay.
5 liter and we have 10 liter. So it's
Mhm.
depend on but for the ER you can go for the 10 liter, something like this.
Okay.
It can be okay.
Okay, thank you.
And don't forget, please don't forget, hospital need light. Okay? And the best thing is to use LED light with less consumptions. This is one, because you have also to manage energy consumption. So don't pick something big. Other points that you can write down is the security light. This security light, you have also to check how many security light you want to put around to be able to have the hospital light during the night. And in the case study, you have also to choose a backup for the main one. So all these things is for you to be able to manage. If you are blocked somewhere or you is not clear somewhere, you can leave things in the chat so that we can move forward. Yeah. Any questions? Question from Noel.
Yeah, once again, so you're talking about lights, security lights. These are things that are not specified in the case study, and I
Exactly.
appreciate that we have to think about it and provide for this. Just like, for example, I think
Yeah.
chargers for cell phones and so on. I see we have the coffee
Yeah.
maker in the radio room, but there are some other items that we have to think through by ourselves. Yeah.
Yeah, but the things is we don't want to go too big, okay? Because light is mandatory. Whatever you do, you need
Sure.
light, and this is a hospital. Second things is a security light, and security light, no excuse for this one.
Yeah.
So we have to take
that's
these
it.
two main things. Yeah, two main things in account. Because as a logistician, if you don't think about these two things, it will not be possible. So security light will be the first things, and then the light in the hospital. Without this one, nobody can work. So you have to make sure that all these things are in your generator sizing.
Okay, thank you.
Yeah. We have
Bulk, I think, was raising the hand.
Yeah. Bulk, yeah.
Yes, sir. My short name is Shahab, sir. So,
okay.
Yes. Sir, you explained about the generator sizing. So most of time we need for the panel board sizing. So,
For the
because we
what?
have great panel board sizing, electrical
Panel
panel
board
board
sizing.
sizing. Yes, we have great power and we need to just size our panel board. Like we have lighting circuit, we have heater circuit and different circuits that we need to more know about the connected load, demand load, and also about the power factors, how much we should take that one. So I'm sure with what training
I
we
didn't
cannot
get
cover all of them.
I didn't get your last things. You said what? Please.
Sir, yeah, sir, we have you all did this explanation was about the generator sizing, yes, that's it. But if you are going to do panel board sizing, we have
okay.
great city power. So we are going to only do sizing for our panel board or for our fuse box. So we doesn't know more about the connected load and also demand load, power factors. So if you have something to share with us.
No, I think this is how can I put it? This is based on your load. Okay, the full load current that you have, this is what you design the system for. Okay, and then your main panels should be based on this one plus the percentage for plus the buffer that you will have. You understand? Your main distribution box must has this one. Now, if you have your generator and you have a city power, okay, it's now depend on you if you want to put a manual changeover or you can put an automatic changeover. And this changeover also will be based on your load. You get the point? So for the power factor and all these things, I am 100% sure that most of the country is okay. But if you notice that the power factor is not good enough, there's a way of correcting this power factor as well by using capacitors. But this you can check with your energy reference, your advisor, so that he can also I don't know the rule for each OC, but it can depend on the decision from your OC. But this for the power factor is not often, but there's a way of correcting the power factor as well.
Generally, sir, I'm asking that we have a proper Excel sheet for sizing the generator, but I didn't see any design like Excel sheet about the panel board sizing. So we have Excel sheet for generator sizing, but we doesn't have any sheet for doing the panel board sizing. So I'm asking this: if we have,
I understand what you are saying. I understand what you are saying, but there's no need to have this one, because if you are designing a system, if you are using a software, for example, to design your single line diagram, your single line diagram with this software is giving you, is balancing your load. You understand? Is balancing your load, and based on this one, you can design your distribution box and then know where to put each line so that you balance the load properly. So this can depend on the software. If you have it and you can do it, it's fine. But if you have a software, it's fine. I don't know which software you are using, but definitely you have it. I think XL Pro, if you use Logran XL Pro, you will see, once you finalize designing the system, you will see that each circuit is balancing.
Yes.
Yes.
I don't know, Caleb, you can correct me also, but I think that this is maybe a job for an electrician, because the technique, I mean, the board in that we have in our installations in the guest house or office or whatever is the job for the electrician. And I mean, this LTT training is for logisticians. Okay, so we are trying to get here the basics of all of this. So I don't think that, I mean, to make a proper installation in an office or a guest house, it must be done by a professional electrician, or I mean, I'm sure that in your in every mission or OC there is the referent and the MIOS and so that give the advice for that. The reason why we talk also about the Excel sheet for the generator sizing is because we, as logisticians, we are involved on all these decisions, and we need to know the relation between our generators and the load that is needed for our generators. But what you are talking is very specific for electricians. It's good to know the different components that we have in our boards, because of course, somehow we need to know what is each device for, no? But I think to build one or to the dimension of one board, the main board, this is more a job of electrician. I think, Caleb, correct me if
no, exactly. And then what we can advise you is that even if you are electricians and you are already log manager or something like this, the best way you know already is an advantage. So you can ask an electrician outside to come and do it, and you follow up with him. Okay, you follow up with him so that you save your time. You have a lot of other things to do. Yes, if there's urgent things to do, like during the night where you cannot, you can take your tools and you can quickly solve. This is an advantage of being electricians as well. Okay, but mostly it will be good for you to call for an electrician and you check on what he's doing.
Thank you.
Yeah. Any other questions?
Thank you very much, Caleb.
Okay, I think if there's no other questions, maybe Miguel, you have anything to add?
Yeah, very fast. Thank you very much, Caleb, for the job. Very good job, and also for all the participants for your comments and participation in this session was, I think, very interesting and productive. And well, this month is energy, so do not forget. If you have any, well, there is a question in Damascus. Yeah, go ahead.
Damascus.
Yeah, please.
Sorry. maybe
No problem.
just
Yeah.
I forgot
yeah.
this question about the generator three phase. If we have a three phase generator,
Yeah.
what's the risk if the phase uh, not
Not
calibrated,
balance.
not balance? Exactly.
It will. It will.
Is a risk for the generator itself or for the dynamo of the generator or
It will. It will
Mhm.
affect both. It will affect both your alternator directly, the winding of your alternator, and
the
also it will affect your load. You understand? It will
Mhm.
affect your load because
Oh, you mean we will not get all the efficiency of the generator? You mean? Uh,
yeah, your because your generator has the engine part and the alternator part.
exactly.
This alternator has a stator winding that is coming on the terminal T1, T2, T3,
And
okay,
natural.
well, which is connected to your breaker. And this, if the load is not balanced, is something is long that I can explain for you to understand. Is a little bit more technical, but it will take time. You know, is the winding, and if the load is not balanced, it's affecting directly the windings of this stator. Sometimes you see that the things is not breakdown now, but in the long run, your generator will start acting up. The output of your generator will not be stable. Even if you have your AVR there, it will not be be good output. And the same thing, this unbalanced load will affect your biomedical equipment
Equipment.
and other electrical equipment. That's why it's
You
always important for you to balance the load.
you mean it will give uh not stable volt? You mean high and
Exactly, and then
Mm,
iron, and then these devices they are designed in such a way to work in the range of the voltage. If it's too much, they don't have this voltage limiter inside to manage.
mm, mhm.
You inside,
That depend on the load on the alternator.
yes, no,
Mm,
but it's both side.
both
It's
side.
because of the load. It's because of the load that you are having this imbalance. If you balance your load properly, your alternator will not have a problem.
Mhm.
You understand? But this load must not be, yeah, you cannot get 100% balance load.
Yes, we
Never.
cannot.
You cannot.
But we
So
have to adjust when we see difference, big difference. Adjust.
adjust. Exactly. Exactly. To get your system healthy, you have to control. That's why we talk about the four priority, and not the third, continuity of service. And
Continuity. Mhm.
and we are there for this one to make sure that everything is working well.
Thank you very much. Sorry for the
Yeah.
delay in the question.
No, no,
Thank
no.
you.
No
It's
problem.
fine. It's fine.
Thank you.
Dimitri,
Yeah, Dimitri.
sorry. Yeah, mute. Yeah, mute, Dimitri.
Yeah, you're muted.
Oh, sorry. Hello, guys. Yeah. Thanks for
Hello,
the session.
Dimitri.
So, yeah, I have one question. If you, like, for example, have the main generator, three-phase main generator, and we want to install as a backup one-phase generator, is it possible?
It is possible, but you have to know what you are powering.
Mm-hmm.
Okay, it's the same
Yeah.
thing. It's the same thing. You have a three-phase generator, but you are installing an PV inverter or a quattro inverter of single phase,
Mm-hmm.
right? As a backup.
Yeah.
So you know what this one is powering. You cannot put all this load
No, of
on
course, no.
the
Yeah.
single phase.
Just, I mean,
It's
like,
possible
yeah. To have
Yeah,
electricity, like use the printers, you know, not the heaters, of course.
Exactly. You dedicate the line that you want to power with this, and then you can be able to manage. You know,
Okay.
for example, in your changeover, you have four terminal, right?
Mhm.
But you are sending only face and line.
No.
Okay. Now, if you want all this line to be connected, you pick, you give this one, you give this one. All these lines will be connected to where you want.
Mhm.
Okay. But
Yep.
you have to be specific on where you are you are powering.
Well,
Otherwise,
yeah.
you will break down your generator.
Yeah. Yeah. Okay. Thank you very much.
Yeah. Okay. It's the same time you are using your inverter
Yeah.
as backup.
Okay. Thank you.
Yeah. Welcome. Any other question?
I have not question, but if it is time to finish for today's session, I seriously thank you, our respected trainers, Mikhail and Clem, for your valuable training and kind attitude. It was really, truly a great experience learning with you, and we deeply appreciated your efforts and wish continuous success. And until we meet again in the last session,
Last sessions.
stay safe and well. And I don't know where is the time for the next session. Where is like which time is we have a last session?
Yeah. So you all of you will receive the team's invitation for the next session by today or tomorrow. The time is the same time that we had this session, so it's same time. The day is Wednesday, next Wednesday, the 26th, so in 1 week. But all of this, it will comes in the team's invitation that you will receive by today or tomorrow. So the last session, as I'm saying, is next week. Keep working on the modules that you have on Tembo, because some of the questions that you are asking, some of them, they may be in the content that is in the modules. So try to work on that modules, and also like this for the next session, the final one, you can also ask for questions and clarify aspects that were not clear in the online part. And also, of course, we will work on the case study. So all the questions that you can have about the case study, we will go on them during the last session. On the other side, if during these days there are other things that comes to your mind, you can also put it on the forum. Like this, we can answer the question straight in the forum for all of you, or we can keep this question for the final session. If we decide that this is something that it has to be discussed during the final session. Apart from that, just to remind you, apart from the LTT energy, that we have, you have already in your fields the form to apply for the LTT telecom on January. The LTT Biomed is starting in 10 days, so maybe some of you, I mean, no, maybe I know that some of you, you are already enrolled in this course. For the ones that wants to attend to this LTT Biomed is a bit limit. You can send me a message or try to follow the form and the procedures, but I cannot guarantee you that you can attend to this LTT Biomed because we have it already at the end. But you are on time for the LTT telecom that starts January 2026. I think that's all. Thank you again for your participation, active participation. I think was very positive for all the participants. And Caleb, thank you very much again for your good work. Anything, let us know in the forum, and see you next week. Thank you very much.
Thank you for all of
Bye,
you
guys.
guys and your questions. Thank you. Anything's missing, we can put it in the chat.
Yeah,
Thank you
thank
very
you,
much.
guys.
Thank you.
Thanks,
Bye-bye.
everyone.
Okay.
Have a nice
Thank
day.
you.
Thank you very much.
Thank you.
Yeah. See you other session.
Okay.
Thank you.
Mhm.